Hello everyone, and welcome to this edition of our DataStax Cassandra Community webinar series. Very excited today. This one's been on my calendar for a long time. It's Valentine's Day, and I'm delighted to have with me today Patrick McFadin, the Barry White of Cassandra, who is going to entertain and educate us today. So hopefully you've got the lights dimmed. A couple of housekeeping items. Patrick will be taking questions at the end of this webinar. So as usual, please use the WebEx Q&A panel to ask your questions. I'll be filtering through those and we'll pose them to Patrick at the end. So Patrick, without further ado, romance us with VNodes.
You know, I noticed you didn't unmute my mic until after you got to say that, right? That's thanks. Well, thank you.
You're welcome. You're welcome. Anytime.
All right. Let me flip this over to Keynote here and get going. So how's everyone doing today? It's Valentine's Day, and here we are talking about VNodes. So I couldn't think of a better thing other than maybe doing something that has something to do with people. But this is only going to take a little while, so you can go out and do something after this. So this is all about virtual nodes, and I'm going to start things out here with just a quick introduction. So what I'm going to try to do today is to make this more like a university class, right? Because we are trying to learn something here. The agenda is really to start with really the basics. I want to make sure everyone's level set. I'm not sure where everyone's at experience level with Cassandra, so just what is a node? And there's some details around that that will make explaining what a virtual node is better, why it's better, what it is. And then I'm going to explain once I know which node a node, then I'm going to introduce virtual nodes, and then how to convert your existing cluster. And I'm sure there's plenty of Cassandra users out there, and that's a question mark. I'm already hearing it, so how do I go from regular nodes to virtual nodes? And actually that's a pretty easy process. So we'll go through that, and then I'm going to talk about some of the benefits of switching to virtual nodes, why it was done. The Cassandra code base is now pretty much all VNodes as of 1.2, so let's talk about why. So in the beginning, since the beginning, Cassandra has always had clusters, and clusters, of course, are what when you set up your Cassandra cluster, it's full of nodes, and those nodes all contain key spaces, which all have column families, which hold your data. And every single column family has a row key. And this is where things really start. This is a fundamental piece that you need to know about how Cassandra works and why virtual nodes and nodes are important. So row keys are all about identifying information inside a column family. Those are the unique part of a column family. So you have one row key and a really wide column, or wide row with lots of columns. And so the row key is that fundamental unique part. So it can be up to 64K size in Cassandra, which is probably big enough for anything you need. And there are two ways to sort those. So the first one is to sort them by using the byte order partitioner, or BOP as the cool kids call it. And if you notice there's a little exclamation point there, that's because that comes with a warning. Don't do this unless you really know why you want to do it. And so you'll hear plenty of people when they're talking about Cassandra and byte order partitioner freak out about it. There's good times to use it, but what you can really probably find more is the random partitioner. And that means that when you place a row key into your cluster, it's randomly put into one of the nodes, and so it tries to distribute the data. So what about that? The random partitioner, how does that work? So row keys, as you set them into your database, how do you create some random number? So that's an important piece. We want to randomize this so that it distributes your data around the cluster. And so how do you make that number big enough so that we can use it and then have it make it reproducible? And that's where MD5 comes in. MD5 is a cryptographic hash, and basically what you do is you take a string and you put that through MD5, you run it through this algorithm, and you get out a 128-bit number. And what's really magic about it is that it always comes out as a 128-bit number. So if I put in my Twitter handle, boom, I get a 120-bit number. Now, what's interesting is that every time I put in that string, the @Patrick McFadin, I'm always going to get that particular number. And that's what's called consistent hashing. And it's very commonly used algorithm. Memcache uses this. Other NoSQL databases use it. It's a very handy way to get a consistent hash. And MD5, even though it's used for doing some crypto, like encrypting passwords and things like that, it was really much better for us now because it's not very strong encryption. It's really better for the rest of us now just creating these big numbers. And so Cassandra's always relied on that. So whenever you create a row key, it hashes it into this 128-bit number. And so that's really important. And that's because we need to have a really big number because you can have a lot of data, right? It's big data. So how big is this number? Well, so the hash is 0 through 2 to the 128th minus 1. So those of you not so mathy, that I put out that number, and there's a lot of commas in there and a lot of numbers, and I don't even, it's like a decagazillion or something, but I don't know. It's big. So Cassandra actually uses 2 to the 127th, and so the bonus reason, so you can stump people about this why is because we take out 1 bit for signing. But still, I mean, tell me if you can tell the difference between a 2 to the 127th number and a 2 to the 128th number, let me know, because you're really that cool. So that's a huge number, so that gives us a lot of keys. Incidentally, little trivia question, or trivia, is a 2 to the 128th is actually the IPv6 address range as well. So, coincidence? I don't know. So, this is a really, really big number, perfect for whenever we need to set this massive amount of keys into our cluster. So, what does that got to do with nodes? We were talking about row keys. What about nodes here? So, let's talk about why this makes sense, and this is going to make a lot of sense in a minute. So, it's all about, so each Cassandra node is assigned a token, and that token is just a number inside of that range from 0 to 2 to the 127th. That's a lot of numbers, but what we're trying to do is we're trying to break up the ranges in all these different nodes so that when you set data in there, it's being spread out neatly. Now, those of you who set up a Cassandra cluster, you know that you create tokens. That's part of the setup. And that token is a really, really big number, or just it looks like a string of numbers. But it's actually a number. It's a divisor of that big number. So whenever you put a token in there, it marks the ownership from, you'll see from token 0 all the way to this, I don't even want to know, I don't even say that number. But that means that everything on that node is going to be inside that range. So what happens whenever I take a row key and I say I'd like to put this into my database, and you run it through MD5, so you can get that 128-bit number consistently, right? So when that happens, now whenever I set data into this, it says, okay, here's your number. This is done at the client, and then finally goes down to the cluster. Here's this big number, which is my row key. Oh, look, I got a node that says, I got it. So that assigns ownership to this. Now, this doesn't have, we're not taking into account replication or anything here. We're just talking about a very simple setup here. But this is, I'm using this to explain a very important concept here. And that is that whenever you have a lot of data and you need to set it into your into your cluster, you need a way to do it consistently. But the nodes, the way that the nodes are arranged and how they are related to the row key, this is how it's related. It's the token. So this brings up, so now this brings us all up to speed here. So now we know when you're setting data in here, this is why tokens are important, where the nodes fit in. But what does this mean in pre-1.2? So this is Cassandra 1.1. This is what everyone's been using up to this point. that means that a node is responsible for all of these keys. And it could be a ton of keys. If you have a 3-server cluster, you're going to have a lot of keys on one server. And that single token is set up so you have one server, one token, and one node. And that can get kind of outrageous. So what the Cassandra community has always talked about is these commodity nodes. You'll also hear people talk about we want more of less, so really small, tiny servers, 1U boxes, not a lot of disk. I mean, that has really been kind of the way we want Cassandra to operate because it works better that way, right? Well, that's not the way people want to do it anymore because, let's face it, if you're racking up a few hundred nodes, which I know companies that are doing this, you don't want to put in 150 servers to do this. You want to try to pack it down, get a little more density. So what you really want is that. And so how do you go from a commodity node, which is tiny little velociraptor, to this big old Tyrannosaurus Rex? And that's a big problem. So we need a new plan. And that plan is packing more data into a single server. And fortunately, we have a solution. That's why we're all here today. So we want to make that one node is responsible for more data. Well, how to do that? So this is where virtual nodes are going to come in. The other thing, and this is really kind of an important, I mean, this is probably one of the most challenging aspects of starting with Cassandra. And it's funny, whenever I get into this conversation with people, because they just look at me like I'm crazy, and that's assigning tokens. And, you have to actually plan this out. So this is serious. Token assignment sucks. I've been a long-time Cassandra user. This is one thing I've never really liked. So that is hopefully something you'll never have to do again. So, and the reason they suck so bad is because you have to do this business of, all right, we need to evenly distribute all the tokens around how many servers you have. And then when you get it evenly distributed and you go to grow it, the guidance has always been, well, double your ring. Well, doubling your ring, that isn't very practical sometimes. If you only need 10% more power, Cassandra is a linear scalar, but if you're doubling every time, that's not very linear. But if you want to put in just, say, 1 server or 2 servers, then you have to do a rebalance operation. That sucks. And then if you shrink a ring, you take out 1 server, you have to rebalance or take away half, and that's always kind of sucks. So this is not good. We don't want that anymore. So the other thing that's always been kind of a pain is that whole business of having to add token into the Cassandra YAML, which is a config file. And I've seen some pretty crazy chef scripts out there that do this. And it's really because that has to be done as the server's coming online so it can insert itself properly in the ring. And if it isn't done, if it's randomly assigned, you're going to have to do a rebalance anyway. So all of this has not been fun for anyone in operations. So let's kick that out. So we have release, virtual nodes. So the whole premise of virtual nodes is that these big servers, these Tyrannosaurus Rex servers, should have many nodes. And these servers can take it. But what we should do is make each one of those nodes very small and make them not as expansive in the range of the keys. And tokens, why are we assigning any tokens? I mean, it's just kind of silly. So it's like assigning a MAC address to your hardware, to your network card. It's just, why are we doing that? This is the 21st century. So we're going to have a whole new plan here with version 1.2. So let's see how this works. So virtual node features, here we go. This is what is, this is probably why you're here. What is this all about? Each node, each server, see, we're going to have to get away from this. I'm saying this a lot too, that we usually say node is like a server, but no, the server and now nodes are different. So you're going to have 256 default nodes per server. And that's kind of interesting to watch. I mean, you can see this, you can see your key range get diced up into 256 different nodes on one piece of hardware, which that's a lot. But if you think about it, that's a really good idea because that's a very small range, and a lot of things come, a lot of the algorithms that work on key ranges, such as doing repairs and doing cleanups are now operating over a smaller key range. That's good. So the auto-assign tokens, yeah, the winning baby's like, yeah, for the win, because now whenever you start up a server and you bring it into the ring, you don't have to assign a token to it. You can't. It has to do it itself. And it figures out where you're at, and it creates all the tokens, and then it evenly distributes it. It sounds magical and kind of unicorny, but it's Valentine's. Feel the love. I mean, this is good. That's what we wanted all along anyway, right? This is going to make operations life so much easier. I'm so glad we have this now, because I don't want to explain to people that they have to go figure out, a divisor of a 10 to the 127th number anymore. So the other thing that we're going to look at improving now that we are creating these smaller key ranges is faster rebuild. And if you look at the way the rebuilds are done now, like when you lose a whole server, yes, you're losing a lot of key ranges, but when you bring a new server back online, and it has a lot of smaller key ranges, we can do things like take smaller chunks but parallel stream in from all the other smaller chunks out there, and it makes it a lot faster to bring a node back online. And when you're bringing a new server online, let's say you do need 10% more capacity or 20% more capacity, you just add 10 or 20% more servers. And whenever they come online, they're auto-assigning the tokens, and they're evenly distributing themselves. You don't have to do a rebalance operation. Yes. Now, there's a new partitioner that we're going to be, the MD5, the random partitioner. There's a new one. I'll cover that in a minute. But this is really, these bullet points are really where VNodes are at. This is what it's all about. And it's not a very crazy topic, but it's pretty revolutionary. Now, the thing is like years from now, people here that, if you've used Cassandra from 1.1 or before, then you're going to be like one of those people like, oh, back in my day, we had to assign our tokens. So, you can brag it up. You got that going for you. So how do you transition? And I'm happy to say this is really easy. It's not going to bring down, you don't have to bring down your cluster. So if you have a running 1.1 cluster, you can transition to 1.2. So here's how you do it. So when you upgrade to 1.2, you can leave it using random partitioner and having a token assigned to each box. That is totally cool. So that's probably how you're going to start. So you do the in-place upgrade. Everything's still sitting there as if it was a 1.1 non-virtual node cluster. So to change it to a virtual node cluster, you go into the YAML file, and you see there's two lines. There's a num tokens and initial token. So the initial token is probably going to have your token for that big old fat huge number that you had to assign to it when you initially created the cluster. Well, now you just eliminate that. So you change it, you just take that out, and then you uncomment the num tokens line and you put in a number. Well, the number is going to be in there by default at 256. Don't worry about that right now. There'll probably be some blog posts on that number and how it relates to your hardware, but for now, it just goes to 256. Then restart the node, just, Cassandra stop or Cassandra restart on the command line. And when it comes back online, you'll see, if you look in the system log, you'll see it stop for a second. All of a sudden, you'll see a ton of, it'll create a bunch of contiguous nodes in that same key space range. So the key space range that older node was responsible for, and then it'll just pick up and keep going. All of a sudden, that node is back online, and it has 256 more, and it'll operate with all the other non-VNode servers running just fine. And so you go ahead and just do that on every server inside your cluster, and when you're done, you'll have a nice setup. So now, once it's done, you have all these nodes going out there. There's one more operation that needs to be done, and this is pretty critical when you're transitioning from non-VNode to VNode. And what's going on is that, like I said, it's creating a contiguous range of tokens so that the range that's inside that server is going to get busted up into 256 chunks, but they're all going to be next to each other. And that's not good. We want them spread out. So what we're going to do is run this shuffle operation. And this is a one-time deal. You only have to do this once when you're upgrading. This is not something you do whenever you start with a 1.2 cluster with VNodes. So there's two commands. There's the create, and so what it does is it calculates, and this only has to be done on one server. It calculates what everything's going to be moved to and rearranged and where all the replicas are and adjacencies and everything. It's very in the background. And once it's done and you're ready for it to operate, you do a Cassandra shuffle enable. And the enable then is a background process. And I put a little thing on here that it's running in the background. This is a slow up. Be patient. No, seriously. It was the first time I ran it. I was like, is it doing anything? But it is. And it's meant to be zero impact if it can. And it's going to take a while. I mean, it could take a few days if you have a very, very large cluster. But that's okay. It's just moving one little piece at a time here and there. It'll take care of it. And if you want to keep track of what it's doing, you can use the Cassandra shuffle ls command. So that's it. So let's walk through I got really cool graphics here. I've learned how to do graphics with Keynote, so I'm feeling pretty cool. So let's do this one step at a time. So here's our existing 1.1 cluster. And so every server has a range of keys, and I kept my key space really, really small because it's got to look good. So I have four keys on each server. So this is my existing 1.1 cluster. So I'm going to upgrade, so I'm going to change that to the num tokens equal 4, and it's going to split these up. So I restarted. Now this is what I was talking about. I have the contiguous range of keys still sitting on each single server as it was before, just broken up into 4 different chunks. So this isn't good. So I'm going to go ahead and do my initialize and my enable. And when the enable starts to run and does the shuffle, it moves all that data around very slowly. And when it's complete, now I have a nicely spread out ring of all my tokens in different places. And this is good because I don't have any replicas sitting on the same server. And so this is the final configuration that I want, is my data is now spread very evenly around every single server. So that is pretty much how it works. So what does this mean for operations? And from what I feel is like the group that is going to benefit the most from virtual nodes is going to be operations, because I was just recently at I was talking to Jason Brown at Netflix, who's one of the guys behind Priam, and Priam was built around the idea of assigning tokens, but now like half of that code is just going to have to get ripped out because none of that's going to be needed anymore. And that's pretty amazing because that's always been the problem. But now, not a problem. So when it comes to your ops life, you can just add 1 node, 2 nodes, 3 nodes, no problem. No balance, no shuffling or anything going on. No token assignments. I think tokens are going to be one of those academic things about Cassandra that's interesting, that people, when they really want to dig into the engine and how it works, they'll know about. But most people really won't know or care, and that's okay. It should be in the background. And now we're looking at building bigger servers. And so this is another operations topic, but it's also good for everyone else who's got to spend money on servers, is if we can start building bigger servers, that's going to make it good. So we're looking at like how many tokens would be assigned to these bigger servers. Again, look for blog posts in the future. I'm actually working on this topic right now, and I want to know more about it too. I mean, what is a good number for how big of a server you have? But it makes sense that you can start adding more and more tokens to a bigger box. And you can have dissimilar sizes too. You can have less tokens on, or less token ranges on one and more on another if you have dissimilar hardware. So also the decommissioning of nodes, which is just like the adding of nodes. So those of you who are living the good life in Amazon with your elastic load balancing and up and down, upshifting, and using auto-scale groups, that's always been almost impossible with Cassandra because of, you have to assign a token and then make sure it's balanced. But I've already talked to a couple people that are working on using 1.2 with autoscale groups, and this should be something that you should pay attention to, because this is where you get that elastic workload balancing with your database. And with virtual nodes, this is a real possibility. There's nothing really in the way other than just figuring it out. And this is a big deal. When you need more database load, you want to scale up, you should be able to just do it. Another thing to mention too for the ops folks is that there is a new node tool command. Now, if you have 256 nodes sitting on a single server, the potential is you're going to have a lot of nodes. If you do a node tool ring, and if those of you who know what that command is, that just shows all of the different token assignments through your entire cluster. If you had just a 4-node cluster, or I keep saying that, 4 server cluster with 256 VNodes per, then you're looking at 1,024 tokens that have to get displayed. So now we have a new command called status, and it just shows you each server, a JVM, that's running Cassandra, and then of course how many tokens are in it. So it's a much nicer way of looking at your ring without having to, pipe it to more, or worse, just watch it stream past your screen. So one more for the baby, the VNodes for the win. So I mentioned that we do have a new partitioner, and so along the same line of, hey, how do I pick a really big number, make it consistent, and hopefully fast, we have a new partitioner called the Murmur3 partitioner. So Murmur3 is an algorithm much like MD5, but it's not a cryptographic one. So it doesn't. There's a little bit. If it's cryptographic, meaning it's secret spy. You got to have. There's a lot of password systems that use MD5, unfortunately. And Murmur3 is not for that. It's not cryptographic. It's just meant to be a way to create hashes. So and a lot of testing has been done. It's slightly faster than MD5. So this is not like ridiculously faster. And so as Cassandra moves forward, we're getting, like I said, bigger, more. It's good to get those incremental changes in while we can. So starting with version 1.2, that will be the default partitioner. Now, I've already got this question, and I'm going to answer it right now. No, you do not need to convert your pre-1.2 cluster from random partitioner to Murmur3 partitioner. First of all, it's almost impossible to do that with any kind of ease. And the second thing is it doesn't give you that much performance increase. It's really not going to be that big of a difference. It's really for the future and as we create new clusters and new setups as we go forward, then that will use Murmur3. But don't feel like you're now in the lower performance tier. It's not that big of a difference yet. So if you don't believe me, this is open source, right? We can go look exactly what happened. So I have the JIRA right here, the Cassandra 3772. That is the entire details from the proposal all the way down to it's committed. And if you've never looked at a Cassandra or any open source ticket in, say, Apache, in the Apache JIRA, I suggest you go do it. It's really interesting, I think. I even have some non-technical users that have looked at it, and just to see and get some insight in the process. And it's very open. As it's proposed, different people talking about it, the debate that goes on back and forth. I mean, it really is out there. There's no backroom conversations and then someone comes out and says, okay, we decided something and here's what we're going to do. No, it's all done right there. So it's pretty interesting. And you find out what the motivations were. And you'll see, like in this particular ticket, how at first it wasn't so performant, and there were some people trying to figure out why, and then they figured it out. So I would suggest go checking it out just so you can understand how the process works. So the conclusion, you can go do this today. This is in Cassandra 1.2. Here's my one gratuitous Valentine's thingy with a Cupid, or as my 4-year-old says, the baby that shoots people. So you can go get it. You can download it. Go to datastacks.com. The community version, that's going to be your RPM and deb file if you want to use that. Or you can just go directly to Cassandra, Apache.org, and download the tarball. This is We're currently on version 1.2.1. If you want to try to test upgrade one of your 1.1 clusters, that's awesome. Go out and give it a shot. It's really cool. And I put these references at the end so you can read some of these. But there's these 2 blog posts that we had. I'm going to put my slides up on SlideShare. So that's more of why I put this slide up. But really, so if you come and look at it later, you can go look at these blog posts, and there's a lot more details about some of the motivations and some of the more detail-y things that you may want to know about. So that's it.
Excellent. Thank you so much, Patrick. You ready for some Q&A?
I am.
Okay. I am going to read you some questions. Just a reminder to those of you, please ask your questions in the WebEx Q&A tab. I will go through those and pose them at Patrick. And just as a follow-up to what he said about posting to SlideShare, we will be emailing out the video archive of today's presentation. If you had such an amazing Valentine's Day, you want to relive it, you will be able to do that tomorrow. Okay, so this one from Steve Broner. Let's get straight into it, Patrick. Does the Murmur 3 benefit over MD5 hold across multiple CPU architectures that might optimize parts of MD5?
Interesting. Well, they're on the micro. This is where the optimization was found within the micro benchmarks, and so we're talking about nanoseconds here. I know that the Murmur 3 has a lot more optimizations, especially for multiple the multiple processor. I couldn't say exactly yes, it's going to be better than that, but I know that from what I've read about both MD5 and Murmur 3, the Murmur 3 in the long run will win.
Okay, thank you very much. Jeff Schmidt and Mike Wendt also both have the same question, which I think I can answer. And their questions are along the lines of, any idea when we'll see 1.2 in DataStax Enterprise? So it will not be included in DataStax Enterprise 3.0, which is slated to drop on February 25th. The big so what around that release is all around security. But we are scheduling a drop of DataStax Enterprise later in the year, which will include all the greatness of 1.2 in it. There's a little lag as we iron out kinks and also do a lot of testing on it, making sure it's ready for production. Patrick, anything to add on that?
No, that is definitely the theme with DataStax Enterprise, is making sure it's baked in. So, I mean, you can go out and get the community version, and really, if you want to play around with it, but you know, it's going to take a while for it to get fully baked out for the enterprise. And think about it, for DataStax Enterprise especially, there's a lot more than Cassandra going on here. We also have to think about how things like Hadoop and Solr are going to integrate now that we have 1,024 or thousands and thousands of virtual nodes out there. So there's some brain cells burning on this topic right now.
Great point. And actually, to coincide with the release of DataStax 3.0, there is a community release scheduled for the same day. That is Cassandra 1.2.2, a more stable release, and that also has some security features in it. So go get DataStax Community Edition if you want to check that out on the 25th. How is replication affected by VNodes, Patrick? And that one's from Rick Matthews.
It's interesting that as I was digging through this initially, a lot of the existing rules are still apply. So the adjacency issues are still there. So you want, for instance, one token, the next adjacent and the next adjacent after that are where the replica pairs live. The only difference is in how those replicas, or where those replicas live. And of course, you don't want two, and this is why the shuffle is such an important operation. You don't want a small node living next to the same or on the same server and have those be replicas, because that would blow the whole point of having a replica if it's not on different hardware. So that's actually that's part of the building of those virtual nodes and then the shuffle part. But once it's done, that's going to be taken care of exactly the same way, where if you do a replication factor of 3 or 4 or 5, it's going to replicate to the adjacent token, but just know that it's going to be on a different piece of hardware.
Excellent. And Jean-Armel Luce asks, is it possible that two replicas of the same row are stored in the same physical node?
Yeah, that's a similar question to what I just answered, and the answer is no. I mean, it's possible, but, well, very unlikely, if at all. And so I was talking to...
Not a best practice. That's taken
No, it's not.
away.
It's not even a best practice. It won't even allow it to happen. These are some of the questions I had initially too, but that wouldn't make any sense. So that's one of the reasons shuffle is important to do. Is it calculates where all the tokens are and the replicas are, and then make sure that those are not sitting next to each other.
Okay, thanks for that. And Chris Trayman asks, in a JBOD or multiple data file directories configuration, do VNodes allocate their ranges across all data file directories? Or does a VNode map to a single data file directory?
Oh, I love that question. And that's actually a feature that I've proposed. So right now, no. The JBOD configuration is load balanced by just the key space and not the actual virtual node itself. I think an interesting thing would be, now that we're talking about virtual nodes and having these smaller ranges and how it would play into larger hardware. Again, if you look at one of the points of virtual nodes is to use larger boxes. So let's say you have 8 or 16 or 24 drives in a JBOD configuration. I think it does make sense in some of those configurations, especially with SSDs, to pin certain virtual nodes to a single SSD. Now, I might get some argument from some of the developer side on Cassandra, but I can see that from an operations side making a lot of sense, because then you're just really sticking to that one. Another topic that's been floated around is pinning on large core boxes, pinning a virtual node to a particular CPU or core. And that also has some benefit as boxes get bigger. I mean, let's face it, 128 core box is not that far away. And do you want to go through the cost from the CPU side of having all these context switches going around and building new stacks as you take the same thread off of the same virtual node and move it around through all these different cores? It may make sense to just go ahead and pin it directly to a single core. So that was like a bonus answer.
Yeah, it sounds like you definitely got a +1 from Chris on that feature. This one from Steve Broner, I will take this one. So Steve asks, are there any early release or dev early Cassandra 1.2 DataStax enterprise versions we can sign up for or volunteer for? And then the hashtag guinea pigs welcome. Steve, the answer is yes. Email me, christian@datastax.com, and I will put you in contact with the right person to enroll you in our early access program. Basically, as soon as we have a version where we're starting to test 1.2, we will roll that out to you. Okay, from Jeff Schmidt. When changing replication factor, does reshuffle happen if needed, or must we execute the command ourselves?
No, you only run the shuffle once. When changing the replication factor, it's going to put replicas on different nodes, so on different physical servers. So yeah, this is another one of those questions I asked early on too, and I've been assured that that is not the case. That the algorithms are built so it will not put replicas on the same physical piece of hardware.
Okay, thank you for that clarification. And John Sander asks, can you talk about setting up a heterogeneous cluster where servers are allocated a different number of tokens?
Yeah, that was one of the examples I had. I went through it really quickly, but again, another conversation I've been having with other Cassandra users is, if you look at virtual nodes and what the goal is to really open up the door for some of these conversations. If you look at, like, for instance, where if you've been using Cassandra for maybe a year or two, you're getting to the end of life on the hardware that it's running on, as an example. So what if you want to transition from, say, a 8-core box to a 24-core box? Well, that's where I think we're looking at creating these different ranges of nodes. So your 8-core box, which is older, you only have 256 virtual nodes on that one. But on the bigger box, creating maybe, say, 512 makes sense, because you're using more hardware, more memory, more disk, more CPU. So you want to try to keep the smaller node sizes if you can, and you're just going to put more data on there anyway, right? So it's just going to, these are some things that I'm actually working on right now. And so, like I said, stay tuned. I'm going to try to put more of these into blog posts about things I'm discovering about this. But virtual nodes opens up these types of discussions and also some new features as we transition from older hardware to new hardware.
Okay, great. I'm just going through. I think we have all the questions answered so far. If there are any last-minute questions, be sure to ask them here. Any last words of wisdom from you, Patrick?
Turn off your computer and go outside.
Great advice. But before you do that, make a note of next week, same time, same bat channel. We have Aaron Morton giving his introduction to Apache Cassandra webinar. He'll also be talking about 1.2 and some of the other great new features in Cassandra. So
yeah, there's a lot of other scaling things that are worth watching for there too. VNodes is only one topic on the make a bigger node, the Tyrannosaurus Rex node. So let's, yeah, that's one I'm going to be watching too for sure.
And a couple of links here for everyone. You know, lots of training events. Probably one in your area. Check it out at DataStax. Check out the new community resource, which is Planet Cassandra. Lots of good information on different use cases out there, and also lots of blog posts and good info. And then if you are on the East Coast, March 20th, we have our NYC Star Big Data Tech Day. We have great speakers presenting, including eBay and Comcast and Instagram, so it should be a great day. If you would like a little discount off of that, use Planet Cassandra 2013, and you will get 50% off the list price, only for the next week though. So thanks everyone. Patrick, thank you again. Go enjoy the rest of your Valentine's Day, and we look forward to hearing again from you soon.
Thanks everyone.